So previously, what we've done is we went from the sigma notation using the limit and going into an integral notation. So how do we do it in reverse? Starting with the integral and converting it to sigma. So there's a few key pieces that we really have to make sure we pick out. The main one is dx, and that's going to be the easiest part because that dx needs to be in the sigma notation as an the I over n, where the I is the interval width. And we also need an f of x part in that sigma notation, and we need to know how the k and n relate to the bounds of that integral notation. Okay, so the first thing is establish the dx. The interval width is going to be 5 minus 3 divided by n. So we have a 2 over n. That is our I over n, which represents dx. Okay, so once we've established the dx in the sigma notation, we have it there. We need to then establish what part of that is f of x and how do we express it. Well, the key to express f of x is to identify the x as I k over n, where I is the interval width, k is the values that we're going to put into our sigma notation, and n is the term that's going to go to infinity. Okay, that's also going to be the k value when we let this go to when we sum up all the terms. Okay, so what we need then is that the x in the x to the power 4 is going to have a 2k over n, and we have this extra question mark here because we have to make sure that just allows us to account for how we get to the starting point of 3. And we can check that by just asking ourselves, if we want to get to the starting bound of 3, we need to start at k equals 1. So we have 2k divided by infinity, and that's going to give us some value that equals 3. Now, because we're dividing by infinity, that term always ends up being equal to 0. So this is always going to end up being equal to 0 at the start. Okay, well that means then that I need to have an extra 3 in there to account for the starting value of 3. The n value of 5, the n value of 5 kind of naturally follows because of that 2k over n. Because when we put k is equal to infinity, okay, so we have 2 infinity over infinity, we're just going to give us the interval width of 2. And if this generates the interval width of 2 for the n, then that should also reflect the x value, because we're going to start at 3 and add that interval, and we're going to end up at the n value of that integral of 5.